Welcome. My name is Michael Wickerson, and I'm continuing with the Grasshopper scripts set trees. This will be the second part of 3, dealing with the nodes and components that are in the ribbon tool sets over in the trees section. I've covered the first few, but I wanted to jump into, after merge and entwine, a little bit of what's going on before we get into, I'm not sure if I get into path mapper again. I think I'll actually deal with masks and offsets. I'll try and make some geometric sense of this as we look. I've used some cones, but I think it might be nice if I did a little manipulation that was a little different. So what I'm going to do is I'm actually going to take this file, I'm going to save it as, I'm going to do sets tree test 002. So we'll just see if I save that one and put it onto the master drive. So what I want to do is grab not just the first section I did, but I'll grab the second section that I did and copy that. I think it copied, and I just want to do a quick paste. I'm going to move that one down. There's some shortcuts for where you can cut and copy and paste. And I'm going to take off all these first ones right here and just put them to disable. So what's happening here, and it might make sense to actually take these as well and put them to pre-disable, and go in and see what I'm actually doing in this first top part. That way I can kind of unclick this and have everything here up and running. So tree statistics is exactly that. It analyzes what you normally see in the param viewer, and here's what I do encourage is to ungroup while you're looking at something, and we'll ungroup something here and see how I start it. And I thought one of the fastest way to produce a tree, which is used quite often in Grasshopper Tutorials, is to grab a rectangular grid system which produces cells. So the plane that's just the default is the XY plane, and then I've moved a certain scale, snapping integers in the size X and size Y, and the extent will go 4, 5, 6, whatever you want. I'm going to leave it as 4, so I'll get 5 points in this direction, 5 points in this direction. And the curves will be separated into sets, 4 sets of 4, which actually are rows of these boxes. And if you think about what's actually being generated there, you can look at it in the panel tool, which people are very familiar with, looking down and seeing that it's broken into these branches. And they all have a wonderful tree indication what it is, and this happens to be a 000, 001, 002, 003. And you have polylines on each section, 4 polylines making up a box on each section. And you can look at that in the param viewer as well, and you start to see these paths that are happening with the trees, or what I consider branches. And then the tree statistic breaks exactly down into that. It breaks the paths out that you can actually read them, and it actually gives you a count on them, which I think I went down here, and here's a 4 count on them. And then I have a param viewer for following these paths. The green dots indicate the 0, and then the red dot are the items at the end of that list. You see there's 4 items at the end of each one of those branches. And I should have said list, I should have said branches. You start to visualize what's actually happening here. So once again, I can go in, and one thing that's nice is if you do explode tree, it works, but you can add to it. But if you add more than the branches, it doesn't come up, and if you add less than the branches, it'll give you a warning. It starts to go back to its orange, and it says, listen, you've contains more branches than this component has indicated branches. So there, when you get it set right, you actually pull. But I'm wary using explode tree and using this way, because when I change the data structure farther up, then upstream, then this has to change and be adjusted. So another example of not just the curves, but the points being gridded out, they're being brought into paths of 5 to each points, because I believe they run around and count the first point twice, at least if I remember that. 1 through 5, 1 through 5, 1 through 5, 1 through 5. Yeah, okay. The tree statistics there, once again, can come out and keep track of that, and you can take a look at that as a tree, and you see it's set up as the same system as the cells were, as curves. But I like dealing in points, and then what I did was, what did I do here? I took the points, and what did I do there? Points are on a different set of 5 branches with 5 points and you can see the data is recorded through in another type of path structure. And I think that's pretty interesting to look at. These are just giving the path structure remains the same. It just has that extra one of 0 through 4. And then these are actually the points themselves of where they're located, because we're dealing with points. We're not dealing with polyline curves. So that should be fairly simple to get through. And when you can wrap your mind around what's kind of happening here, I'm going to hopefully make this a little more complex. Put it back into the group, send it back into the color that you prefer to know you looked at it, and let's look farther downstream as to what happens. List item is a great tool for data paths and branches and items. And so I have the number. I brought in a list item to those tree branches of what I brought in. And what did I bring in? I brought back the cells, and we know how to read the data in the param viewer and in the panel tool and in the tree in the param viewer. And then I can actually take a look at each one of those paths and see what makes it up. And this is just the slider. So when I'm taking a look at that tree branch, I can actually move through them. And I see a lot of people do this, but once again, it's not, to me, the highest form of programming and coding and understand what's going on. List items, explode trees seem to be kind of a breaking down of the logic into a more 3DM file or Rhino-based need or articulation or visualization. And then I did the same with the tree item. I thought was nice. That I actually brought in the same tree, if I believe, from the cells. Yes, I did. And I followed the path coming out of way back here as the tree statistic paths. And I was able to go into the index in this direction and pull out the rectangles. If I slide through this index, you see I can move it through in the horizontal. And it just keeps wrapping around as I go because there's a lot of different numbers there. So I'll just leave it at 0. So tree item is a little different than tree branch. And that might be nice to start relating those geometries and finding out how you can actually build some pretty geometries by rolling that through and then rolling through this tool as well. So if we actually indicated this one here, it might be nice to see what happens as I move through this slider and pairs data. And when you start getting more, this can drive some pretty interesting geometry. So I left that there for a little playful tool to start understanding just as a grid. And we're going to get a little more complicated as we move into 3 dimensions at 7 minutes. So let's do a quick group, and let's pull that back into a color that recognizes I kind of know what I'm following. Let's go down to the next section, and before we do that, we'll take all these stats and put to disable. We'll go down here to this section, and we will ungroup. And we'll say, okay, let's enable what's happening in shift paths. And shift paths is going to get a little fancier as we get into here and see what we can do with masks. What I've done here is a Daniel Kristof style tree construction, which is basically building a grid of points by a cross-reference graph, which runs through a series. And if you don't understand that, I have done it in earlier videos, but it's something to start wrapping your head around and think about how you can get a better count, how you can explore that. And what I did here was I put a point list on each one. As we go in, you can see how it's being counted. It's being counted 1, 2, 3. It's being counted in sections of, if I roll it around this way, those points are a little small. Size, let me up the size so you can see what's happening. I'm actually counting 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, and I'm doing that 3 times. So in looking at the number and using the point list visualization, you can start to guess what that probably looks like. And a great example right here will be 3 paths indicated by 2 0 paths. And you can take a look at the tree. You'll have these 2 green dots that aren't doing anything. So through the first path, second path. And then the third path holds the elements or indices, and that's where you have the 9 items on each one. So you start to visualize that, and you can always go back to the panel and look at the points. So the deeper your logic and the deeper you understand it is, the better. Shifting paths is pretty nice because what's happening when I shift paths? Now the visualization here, the only way to really tell as I shift the paths here and through, I thought the colors might change, but you can see what happens. If I shift back, oh no, this is a shifting of the paths and counting what's happening here. And this can be a little tricky. You've got to watch the param viewer to see that if I leave it as set at 0, then I have the regular path. It's like putting it through Path Mapper in a sense and doing nothing to it. You have those 3 paths all indicated on that last branch, and this looks the same. But if I shift if I trim one off, and I move here, you'll see that 1 green trim came pulled down here, and all the items on that list were pulled back. But it doesn't make a big difference here, except you see your paths got shortened to 0, 1, 0, 0, 0, 1, 0, 2. If I shift that 2 paths, it's kind of like preparing that for a flip matrix tool where I can actually do something pretty interesting with this data now in tree. I'm going to jump ahead and just jump in the flip matrix. But I can go into here and have another one of these that I've actually swapped the number system over here that I've made 9 branches with 3 items on each. And that's going to totally change how this number system works. So I take those points, and there you go. You've run it in a totally different direction. And of course, I want to make it so I'm only looking at that one. And keep in mind that I've actually shifted. I've made 9 areas, so you can actually count here 0, 1, 2, 0, 1, 2, 0, 1, 2, and then have to do it again and again and again. You put 3 items on 9 different paths. So that can be a powerful tool. I don't mean to complicate it with that, but I thought it would be a good visualization tool to see what's happening. I have a size here. Let's put back in our points, and we'll see what we had initially as counting from 0 through 8, and 0 through 8, 0 through 8, 3 different times. But shifting paths is also nice because you can actually pull the paths back. If you watch that other one, you can pull it back, and then it kind of flattens everything. It doesn't even have indication of the indices, and it's counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and going all the way up to 27. I'm trying to put it in order so that you can actually see the count. And whenever you want to see something that's maybe a little tricky to see, you can use your visualization tool to shrink it. So that's actually eliminating that first branch that had all of that breakdown of what was there, keeping those on separate branches. So that's a tricky tool, but it really, in the sets list, is a sense of trying to understand this on different levels. Now, that, of course, is getting more complicated, but I think we can say for sure that it is manageable. We're going to try and complicate this even more. Let's pull back into, we can actually see that, and I will grab these shift paths, and I will disable them, and we will come down here to this middle section. Partly what I might do is just grab this section first, which doesn't have any visualization, and enable. And this one I might leave on. I just want to take a look at constructing a path, making a path, finding a way that you can, with the gene pool or number sliders, just create whatever type of path you need if you have to solve a problem and match your data. And you have to put these paths to the equal amount of numbers. And that's a power to do that. And then there's a deconstruct path to look at those. So there is 2 tools, construct paths and deconstruct paths, to actually create your own that might actually solve some problems for you. But once again, it's not really the smartest coding, I think, when you're doing that, but it's nice to know that tool exists. And then there are stream gates, which are nice. I had an example here of what I was doing. I'm going to see what exactly I was doing. This is a swapping and moving from the 0 gate to the 1 gate and pushing that stream through. So you can see that I pushed it through on the bottom gate, and the first gate I pushed it through the 0. And then the same thing here as I bring in a multiple tool and go to stream filter, and I do the same type of thing. If I push it through the bottom, it's going to say no data is coming through 0 because that's what's happened here, and the 1 data is the one that's being filtered out, so you're getting no data. But stream filters and stream gates work obviously with paths, and you might want to end up using those as tools. A little abstract. When you put them to use and you see them as videos, they should be kind of familiar, that you've thought about them or seen them or taken a look at what all of these tools might do in here. I'm going to take this one to disable and get into something a little funkier and a little more fun. And this comes out of BIM Corner and a little bit of Daniel Kristof as well. And I'm going to play a bit with this. I'm going to try not to make this too complicated. So let's jump in here and hit ungroup. And I have a tool here because we talk a little bit about GH-Python nodes and C# nodes. But I've actually written in a construct tree number, which is a nested loop. And you're basically taking, I'm using branch number as a variable, count number, and number to represent as this opens. Hopefully it will open. If you're not familiar with C# or all the things that are happening here, I don't mean to confuse you. I think I actually will close up a few of these so you don't have to worry about it. But this is the run script that's in here. And it literally is producing a tree. And it might be best if I showed you that tree of what's actually being generated, and then possibly put it in a param viewer of what's happening. And then beyond that, I could actually show you a visualization of what's being created. So I have a script that will simply run as a nested loop, branch numbers, and basically feeding in GH paths path indexes and list numbers in the end, that you can actually have numbers representing a numbered tree. There's a numTree.addRange function down here that's being used. And watch my tree as I play around a little bit with that. So you can have some really nice manipulation of creating your own trees. This one's not doing anything because that's the count, and that's dealing with the indices, but you can have control over how many branches you actually want. 1, 2, 3, and then default none. I think I had it set 3, 3, 3, and you can see the data running through. Not going to spend too much time on that, even though I think I might take these two and pop those in to add to group. But I put a little red warning on there because that's something a little more advanced to get into scripting and coding, which I don't think we're doing in this MGSM series to start, even though there's been some questions and interest in doing so. That would take the static modeling through parametric modeling into more computational design, and we'll see where that ends up going as compiling scripts. So what I have here is the same old point grid, and it's fairly simple, but with the point grid, I've already have it broken out into these sections that I think it might be nice to go back and do something here. Well, no, we'll leave probably won't. We've made it the geometry of cones that we're dealing with, but I actually want to start thinking about adding the cones later. And I'm going to show you why I'll do that. But right now I put a cone on each one, and you have the points of where they're all being driven. You have the param viewer, and you have the tree to see that. But you can take a split tree node, and I'm going to leave it up to you like I did in the last section. I'm going to leave you two nodes, path compare and replace paths, that require. This one requires a mask, and this one has a replace kind of function on it. That they're dealing similar with what's happening in the split tree, but I want you to find out what's different about it. And you'll see there's a bunch of nulls and there's a bunch of untrimmed surfaces here, because I'm actually masking out. It's literally, I think of it like putting tape on things to cover things up so you can't see it. So we're covering up points, and when we cover up points, we're covering up point attributes, X, Y, Z, so we're covering up locations. And BIM Corner has an incredible exercise here of not just using different types of masks. So if I took the first one and said we want to take a look at path 1, out of all this data that came through here, all these different paths that came through, which you can see indicated, we're going to choose anything that has 1 and then only choose the second element in there, starting count at 0, 0, 1, 2. So you're going from, if it makes sense, this system to this system, which is actually just selecting the 1. And you can select all with the asterisks. So you select everything in those paths on the set on what I would consider B and C, and then you're choosing the not 0 elements and not the 2 elements, but you're choosing the 1 elements. This one's choosing everything, which does the exact same thing as the one before it, because it just defaults that 0 wasn't doing anything anyhow. So these masks all have different ways of writing, and there's some nice cheat sheets on how to do it. I'm going to grab down here and take a look at what this mask does, and what it does is it says we're going to take that first row, but we're going to take 0, 1, 2 in that row as elements. And that's exactly what that ends up choosing from those originals. And if I go back and choose the same ones, I say, let's choose 1, 2, 2, you'll see that when the 0 drops off of this one, because we're actually just choosing 1 and 2. There's many ways to write that, but the reason you might do 0, 2, 2 is if we actually amp up our game a little bit and say, okay, let's take a bigger count. Let's take a bigger count of 5 and deal with a much bigger set of data. And now, as I put this into 0 to 2, I might want to go from, let's say, and this won't work in my initial example, but I wanted to get a little more complicated. I wanted to choose particular items, and there you go. I've chosen a very strange system of choosing 3 to 5 on path 1, and I have to, my count, because I went to 5, hang on a second, I'm going to go back to 2, loop through. So I'm going to go back to 2 to 4 and see what that ends up doing. And I think then I'm going to have this section in the middle because it skipped a 0, 1 and left off 5. Actually, that's not really what I wanted either, because I'm thinking geometrically what's happening. You always have to remember you're counting at 0. Let's go for 1 to 3, and that's going to choose the middle 3 elements and leave off the end one. So there you go. You've got that. A little hard to see here, but it wouldn't be bad to see in all 4 views of what's actually being selected as the grid. And probably this grid would be good to look at, and this one would be good to look at. But then again, the front and right view will make that sensible as well. I'm going to stay to this group. The next one is to go 3, 4, and keep counting. And that's exactly what that did, counting all the way up and never stopping until it finishes that middle, well, not middle, because we're now counting by 5. So it's a little tricky. You've got to wrap your head around the geometry. What geometry is that mask selecting? And it's selecting definitely that geometry throughout it, not counting 0, 1, 2, but starting to count at 3 and going all the way to the end. 4, 5, 6, 7, 8, 9, all the way up to 25. I should say, should do what Jose Luis does, blah, blah, blah. I like that. So this one's a little different. How is that one running? That's choosing 3 through 7, but since it loops around 3, 4, 5, 6, 7, that makes sense. And I'm staying to that not 0 path. Think of this as bookshelves. I really do think of these. I should probably making rectangles here as books and turning them 90 degrees so you can actually think of them on different shelves on different racks. And then he shows an example at BIM corner that you can go from 3 to 4, or you start using conditionals and things, and your coding starts to amp up a bit in maths, but I keep it pretty basic. So it's either going to choose that, or it's going to choose 7 to 8, which can be a nice way of actually thinking of data. Now, what does BIM corner do? I think is pretty amazing. They go back and they say, let's grab all of these items, but let's only choose 0, 2, and it will think 4, 6, 8, 10 till it's done. So you're choosing those every other paths, not the whole thing. You're not choosing everything here, which would be all those points. You're actually only choosing the ones that select here every other one, and you're choosing all of the paths to choose from, and then I'm selecting everyone on that path. And then doing that mask, I can actually grab that geometry and I can move that up, but I've actually selected. And BIM corner is really nice in building geometry. It doesn't have to be cones here, it can be anything. They actually then go back and merge that back in with the original, what wasn't selected. So this ends up being a selection of these with these. And you can start to see how you can start to control some incredible geometries. Just the points of where they are. And what I would suggest is maybe we keep dealing in points until this point, and we actually take these geometries and put them to, let's just do a quick, this might turn a little messy. Let's grab those geometries to these circles, and let's grab these geometries to cylinders. Let's just see how that works out. And there you go. Then you can merge those two in here, and you start to realize that from a single data system, you can start to have some really nice parametric control. And I think if you make your mind, it's going to slow down because I'm dealing in solids. I should probably be dealing in meshes. But if you can actually wrap your head around controlling data in a sense of shelving or of tree data, what you want to select, and you can use masks properly, you will just amp up your game crazy. And I'm just going to kind of leave this mess here because that's what I was playing with. I'm going to group all that. And once again, when you make a derivative of one of my scripts, please go in and consider making it a color of something you can kind of wrap your head around. I'm just going to leave that in there because this is tree data too, and always make a test and copy your data as you go down. What's the last section I wanted to talk here? And I think I'm a little clearer in the morning than I am at night when I try and do these things, but I do want to help you organize your data, think computationally with it. You're getting so close with maths and interested in going into scripting and coding that I think at that point you're ready to make the jump with Jose Luis and Parametric Camp into custom nodes within C# and Python, and then possibly make the jump where I've gone. Certainly, I know many online like Jose Luis can do that, but somebody like Daniel Kristof that tucks all of these scripts, and he's done it for me, we've collaborated, starts rolling those in the Visual Studio, you start to produce some incredible plugins. And of course, the one I want to put a little plugin for is the Conic plugger. We've had a couple hundred downloads and installs, and that's the mathematic interest I have, then seeing them run incredibly through their own node system. And that's the Dominion you can join. It's called Each One Teach One, and I'm promoting that as much as possible as open source as well. Let's take this one and go to ungroup. Let's take the match tree, and I said note simplify, and let's enable that and see what we actually have. And this is a little exercise that architecturally, I think it's a great exercise in data. So I've used the rectangular cells here, I've used the rectangular cells here, and all I've done is changed the plane. Whereas the original, I think I probably, if I click on here, plane origin, yeah, I clicked the plane origin, made it XZ plane, and this one defaults to a XY plane. I made two different grids that can change their size and scale. Their extends, so it's a little different on each one. I'm looking at the data as a panel. I'm understanding the data as a param viewer, but also as visualizing a tree. And you can see there's additional, obviously here there's going to be an additional couple of zeros here. This one's actually only going to have one, which is easy to flip a matrix. And this is where you might want to get into adding things, manipulating your trees, which I showed farther up. Matching tree is interesting. These are different. And that's exactly what match tree does. It takes this tree and puts them to a similar, it makes this one behave like the guide to this one, and this one behave like the guide to that one. And that's a little something for match tree, and I've yet to figure out, but I'm sure in robotics, and I think Sujay is going to cover that. Hopefully some of this, when it comes to understanding. Omar Ghanetti at the American University in Cairo really did a beautiful job of showing me how to manipulate surfaces and planes and data and understanding data trees. And I don't know if I still have the recorded video, but one of the best examples of using bookshelves and shelving units and compartments to understand what you're doing. If you're an architect and you think in kernels, mailboxes to apartments to floors to buildings to city blocks, you're going to have to wrap your head around this. And the multiplicity, anyone who's working static in Rhino and creating beautiful models might be creating solid objects or hollow objects, but singular objects. And lists of lists are one thing, but lists of lists of lists are another total monster. I've got a little phone call here. Can you just put it down on step, and I'll get it in a minute. A second. Just put it down on step. I'll get it. Thank you. It's my youngest, Ella. And I think I've done this section, so I'm just going to close this up as a group and say I've at least taken a look at match tree. Try not to leave any component left unturned, because while you're in a section like something as complex as sets, keep in mind that I say 20-80 rule. If you know your 20% of the math, sets, and vectors, you're going to have an incredible understanding and move forward without knowing everything into the other ribbon nodes. The last section I'm going to visit is this one, and we'll do that in the next section. I'll do a little refresher of the geometry here, but as I visualize that and pull it in, I'm not even sure. Ooh, it's taking a moment to get angry at me. It must be a big file. There it is. We actually can see what's going on there. A little bit of geometry and control as I move it around using the same kind of grid pattern, the same cones. What I've found is teaching is if I state the same things and use the same technique of these grafted cross-references to build these point grids, it becomes familiar to you, so you're able to wrap your head conceptually around the computational things that are happening, certainly within the tree lists. And we're going to spend some time on relative items. One thing to take note of those is this offset tool, which somewhat looks similar. Looks a little similar to kind of what was going in with masks. And that's what we'll cover in the next video. I've got a little problem with my capping holes here. We'll find out why. And what I'm doing, like I could have done in the last one, is rolling these into some really nice multi-pipe tools. And I don't dare do it here. Oh, let's do it. Let's just do it to entice you to stay with the program. Preview on. There you go. Nice multi-pipe that when these start to connect, it will make some nice geometries and some nice forms. And you get a pretty sweet little model that you can change the count. And then, of course, control the data through relative items. And it's a little slow to move because I am dealing in the subdivision tool, which can take a little more time, and you'll need your profiler on to see that. In the end, you've got an incredible way of starting to understand the sets list tree component, which I think has not just lists, but sets tree components. And when you put them all to good practice, you're just going to advance your game to advanced, well, intermediate, but then moving towards even more advanced scripting and coding. Fairly repetitive, stretching it 30 minutes. We still have one more section to do on this one part of the ribbon tool, which is probably the last one people get to, but probably the first one they should have gotten to. Thanks again for watching. Michael Wickerson, Wickerson Studios.